Hey everyone, and welcome to The Explainer. Today, we're diving into a massive tension right at the heart of the AI engineering world. I'm talking about this huge, widening gap between building these incredibly flashy, multi-agent AI demos and, well, actually surviving a ruthless, real-world regulatory audit. It's kind of where cool tech goes to die if you aren't paying attention. So let's jump right into this, because it's a trap a lot of brilliant teams are falling into, and the stakes, they're incredibly high.
To show you exactly what I mean, let's talk about Sentinel Mutual. They're a fictional mid-market insurance carrier, and they recently built this really cool, high-speed, multi-agent AI triage system for their commercial underwriting. And honestly, in testing, it worked like an absolute dream. It dropped submission processing times from 19 minutes all the way down to a lightning-fast 8 minutes. Huge win, right? Well, then reality hit. During a massive exam by the State Department of Insurance, regulators pulled a random sample of 47 bound quotes. Out of that tiny sample, 4 were immediately flagged.
Now, the reason they were flagged is pretty much a nightmare scenario for any product owner or engineer. The regulators literally stated, rationale not reconstructible from logs. Sentinel's blazing fast multi-agent system couldn't actually explain how it made those specific decisions. What happened was, one AI agent was quietly re-summarizing another AI agent's work, and that original data trail, the actual source data that drove the risk score in the first place, was completely lost. Poof. Just like that, their entire product rollout was on the line. To figure out how Sentinel ended up in this mess, we really need to diagnose their architecture.
Section 1. The Suspects. We're looking at the Autonomy Continuum.
Okay, so you can think of AI autonomy as a 4-tier ladder. Down at the very bottom, Tier 1, we've got the deterministic pipeline. This is your standard old-school code. No AI making routing decisions, just your basic predictable if-else statements. Then you step up to Tier 2, the chain. Here, you're using large language models, but they're in a fixed sequence with bounded, very predictable branching. Step up again to Tier 3, and you hit the single-agent loop. Now the AI is making dynamic decisions, right? It's actively choosing which tools to use on the fly until it solves the problem. And finally, all the way at the top, Tier 4, the multi-agent graph. This is exactly where Sentinel Mutual was playing. You have an N number of agents, each with their own AI, sharing state and making highly dynamic decisions together. It's powerful, for sure, but it's incredibly complex.
Moving right along to Section 2, the murder weapon and the expanding failure surface.
Here's the catch. Every single time you step up that autonomy ladder, you are drastically expanding your system's failure surface area. I mean, it's not a small bump. According to the 2026 LangChain State of Agent Engineering Report, a staggering 60% of production agent incidents trace directly back to state management failures. When you've got multiple AI agents trying to read and write to a shared memory space at the exact same time, it gets incredibly chaotic really fast.
When you decide to upgrade to a multi-agent system, you're basically inheriting a whole laundry list of terrifying side effects. We're talking race conditions, state divergence, massive accountability gaps, eval explosions, tool drift, and debug loops that can literally spin out of control for hours. These aren't just minor little bugs you can patch on a Friday afternoon. Actually, scratch that, they're worse than bugs. They are fundamental architectural vulnerabilities, and they multiply with every single step you take up that ladder.
But the core vulnerability here, the real culprit, is what we call the accountability seam. This is the exact point in an AI workflow where the ownership of a bad output becomes, well, entirely murky. In Sentinel's case, Agent B accepted Agent A's reasoning without ever verifying the underlying source data. So, when the regulator knocked on the door and asked, "Hey, who owns this bad output? Why did the AI do this?" nobody could trace the reasoning back to the source. The accountability just vanished into that seam between the two communicating agents.
All right, Section 3, the solution, the 4-criterion scorecard.
If you actually want to survive an audit and build things effectively, you have to mathematically justify stepping up that autonomy ladder. And forward-deployed engineers use 4 strict criteria to do this. First up, decision branching depth. How many forks does your workflow actually need? Second is tool routing volatility. Does the AI really need to dynamically pick from a growing catalog of tools per input, or is the routing fixed? Third, your auditability budget. How much regulator-facing explanation are you going to need for every single step? And fourth, that accountability seam. If an output is dead wrong, who or what exactly owns the bug? You score your workflow across a chain, a single agent, and a multi-agent architecture, and that tells you your true winner.
And this brings us to a huge, foundational rule of AI engineering.
one that's heavily backed by Anthropic's research. You absolutely must default to the lowest autonomy tier that meets the brief. Every single step up that ladder is justified only when the prior tier provably cannot get the job done. I mean, you don't just build a multi-agent system because it makes for a super cool vendor demo, right? The default should always be a simpler, deterministic chain workflow, unless you have undeniable, rock-solid proof that an agent is strictly required.
Finally, Section 4, the resolution. Let's apply this scorecard to Sentinel Mutual and fix this.
When Sentinel's engineering team actually sat down and profiled their workflow against the scorecard, they realized something crazy. 81% of their submissions followed a really simple 3-fork path, and the tool routing was completely fixed for each fork. The results were undeniable. The simple chain architecture absolutely crushed it with 20 points, while that flashy multi-agent system scored a dismal 5. Why? Because the multi-agent system was inventing complex branching that the workflow simply didn't even have. Its highly dynamic nature was actually an anti-feature for a strict, highly regulated insurance process.
So the contrast is just stark. On one hand, you have the disastrous reality of a cool, over-architected demo, murky accountability, invented branches, and a totally failed audit. On the other hand, you see what they achieved by just rolling back to a simpler chain workflow. A chain forces you to log inputs and outputs at every single boundary. It relies on fixed routing, and most importantly, it produces an audit trail that a regulator can actually reconstruct step by step. It allowed Sentinel to finally, confidently pass the exam. As we wrap up this explainer, I really want to leave you with a challenge. Take a hard look at your own production workflows right now. Seriously, ask yourself, is your multi-agent architecture genuinely justified by strict criteria, or is it just a really cool demo? Are you carrying the immense, crushing weight of state divergence, eval explosions, and accountability gaps for literally no business reason? Remember, default to the lowest autonomy tier. Protect your accountability seams. Because when the audit comes knocking, a brilliant but unexplainable system isn't an asset, it's a massive liability. Thanks so much for joining me for this explainer, and I highly encourage you to take this scorecard back to your engineering teams today.